Dr. Wagner. I'm very happy to meet you again. Last month, we were in Montreal for WTC 2026. But in such a big conference, we cannot find enough time to communicate. This time in Shanghai, in this studio, I would like to have a deep conversation with you. And we can talk about several points. But first, I would like to ask you how you developed your Dowel systems maybe 40 years ago or 50 years ago. And we know each other over 30 years ago, but I never asked you this question. Today, I want to use this chance to ask you the history about your innovation, why you developed Dowel, and how you developed the Dowel, and what's the improvements with the time when you're using it in the project?
Actually, we have been working on the design for the Munich Metro, and it was about the year 1974-75 as a company by the name of Betonmonierbau. At that time, we have had only the experience from TBM tunneling in Frankfurt. It started in Frankfurt, and it was a famous German company by the name of Weiss and Freitag. We have modified the system from Frankfurt for the city of Munich. And we started with the design of the segments. The number of segments was just huge at the time, different segments, more than 60 different types of segments. And it was a challenge for the production of the segments. When we have designed the segments and started for the installation of the segments for the Munich Metro, we had big problems because of cracking in the joints, both in the longitudinal joints and in the transversal joints, and cracking was just not satisfying to the quality and the needs for the quality. We started to think about what can we improve. We always want to improve technically. At that time, we first had the idea to control the longitudinal joints and not first the circumferential joints. The longitudinal joints we could more easy improve by installing some help, some mechanical help, and it started with plastic longitudinal insertion into the longitudinal joint.
Why you do not consider steel one? You use the plastic one.
we used the plastic one, and basically at that time it was an environmental reason also. Steel was not environmentally friendly, but plastic. And originally we have had plastic from the garbage, from yogurt. So that was environmentally friendly and cheaper also than steel. Later we thought, okay, we can improve the longitudinal joint, but we also have to improve the circumferential joint. And for the circumferential joint, we thought to replace steel screws and have, instead of steel screws, we wanted to have some environmental friendly also plastic. And we started to think about researching and talk with the manufacturing companies of the segments, and then we had the idea to have dowels, dowels which not only better connect, but also improve the quality of the ring. At the same time, reducing the number of different from 60 different segments for left ring and right ring and correction rings and on to only one type, one unified type of ring, and using plastic dowels for this unified, for the assembly, for the assembly of the erection of the ring, and for the better quality and reducing the number of damages also. So the quality was improved, the economy was improved, and the economy from the point of view of construction, different types of segments also. So it was a big step forward, and it was kind of convincing the industry that dowels are not only improving the quality, but dowels in connection with the longitudinal and the circumferential joints will give a better quality. And very soon it was used worldwide, globally, you know. It was used in Mexico, it was used in Korea, it was used for the metro of Washington Metro, for the Los Angeles Metro. And in Europe, it also went from Munich to Stuttgart, and from Stuttgart then further back to Frankfurt. So it was really a breakthrough.
You are right.
It was.
It was also used in China, in Yellow River Diversion Project.
And it was used in China for the Yellow River Diversion Project, because it was like a virus, you know.
Yeah.
So it was really astonishing. And now, 30 years, almost 40 years after that technological breakthrough, it became a standard worldwide. Everywhere it is used. If I come to a country like Colombia, you know, then I go to see the construction site, and they are using the dowels, and they are using the longitudinal improvement of the segments. So it's just amazing. It has been a patent also. Originally it was a patent in Germany and in Austria, and later it was also patent protected in the United States. And in 1995, you know, I separated from at that time MyRadar to MyRadar Consult, and it was my own company. I was the main shareholder of that company, and it has been used in Paris. It has been used in so many other countries.
Yeah, in Paris Metro, in one project, I still remember 30 years ago, and I saw the plastic, it's called nylon dowel, but inside it, you insert one steel rod inside it. And the local project manager told me this steel rod inside it just to increase the stiffness and the strength of the dowel. Is it also your improvement?
There have been many details which have been later on improvement, you know, but the primary goal was originally to develop a plastic dowel, which, for instance, for Boston Harbor tunnel, which is a 16-kilometer long tunnel for the outfall of the Boston Harbor, you know. It was used wooden dowel.
So wooden dowel?
Also wooden dowel. Thousands and thousands of wooden dowels, which have been produced in the United States to improve the circumferential joint, and it has been very successful at that time also. And now there was a company, American company, and they have adopted it. So the original idea has really spread globally, worldwide. in the tunneling industry.
So, in my understanding, actually, you start from 0 to 1, and then 1 to 100, maybe contributed by the whole industry, right?
Correct.
It's
correct.
very interesting. It is actually very important. We need many 0 to 1. It is more important than 1 to 100.
Yeah.
Yeah.
That's the original breakthrough.
I think that is your great contribution to the tunneling industry in the world. I really appreciate your contribution.
Thank you.
So, Dr. Wagner, and we are old friends for over 30 years, I think. And I know you worked for World Bank before, and also you worked in over 30 countries, I believe. And then you are the former vice president of ITA, and you also involved some innovation like Dowel System. Now it's very famous in the world. And you also involved in the Color Canoe project and published the book like this one. So let's say for the past 50 years, okay, you have done a great job. I mean, very successful in my point of view. And now I want you to give young generations in tunneling industry only, let's say, 3 advice. So can you please? Only 3.
Okay. Let me just make a short view into the past. And I should mention that I started as a blue-collar worker when I was 20 years old for the biggest hydropower station in Austria called Kaprun Hydropower Station. I was working in the excavation area and in the mucking area of that. And so that means that I started to gain experience from the very, very basic facts how to make a tunnel. It was the initial thought also that I would like to spend my life in that material. And then I started to study civil engineering at the Technical University in Graz, and I became also an adjunct assistant professor for rock mechanics and foundation engineering at that time. After I finished my degree as a what is called a master's degree, it is called Diplom Ingenieur in Austria and in Germany. In the course of that work, I was faced with problems like the problems of the quality of precast concrete segments. And the result was that devices have been developed based on research projects for the better control and for the better quality and for the better economy also of precast, TBM-driven precast concrete tunnels. Now, I started to work in different parts of the world. First of all, I started in Germany, and from Germany, Frankfurt, Nuremberg, Munich, I came to Washington Metro, and from Washington Metro then to Colombia, to Mexico, and even in Korea. I have been working for the Metro of Korea at that time. I got a very good feeling of what the market, let me use the term market, what the market of tunneling in the world is. And I understood that we have had 2 developments. One is the increasing of the world population. When I was 20 years old, we had a world population of 2 billion people. Now we have a world population after 50 years of almost 9 billion people. That means that where are the people going? The people are urbanizing the planet, and most of the development happens in the coastal areas of cities like Shanghai, like New York. You can take any capital in the world. So there is a need for more and more underground structure for different purposes. We need underground structure for mass transit. We need underground structure for hydropower projects, for flood control, and so there is an permanent increasing market. Means that also we need engineers. That means that we have to educate engineers, and we have to organize what we in the International Tunneling Association do. We organize lecture series either on an international level or on a national level, like for instance in China or in India or in other big countries. So there is a need for young engineers and for educating young engineers. And what my mission is, I like to make young engineers enthusiastic about the civil engineering and tunneling part of the underground structure. What is the real challenge of the underground structure? The question is, what is really making me interested? And I think the most interesting part is that only in underground structure you have to have control over two disciplines. One is structural engineering, and the other one is geotechnical engineering. So the combination of both structural and geotechnical engineering gives you the basis for successful project implementation. That means that every young engineer who decide not to go into law or not to go into medicine or not to go into any other discipline, but go underground, go combine and get satisfaction also by combining structural engineering and geotechnical engineering and have successful projects. So successful projects does not only mean that we need good contracts, but we need also good understanding of the design, and we have a lot of responsibility to take where we have to give support to the politicians. Politicians usually are not engineers. Politicians in the most cases are either lawyers or are either other disciplines, but the real satisfaction comes from this challenging combination of structural and of geotechnical engineering. So that gives me a lot of satisfaction also to see if I can create enthusiasm on the young engineer side and see them succeed and be happy and have fun with the work. I think this is the most important. If you are working very hard but you don't have fun, sometimes you get so tired that you don't want to work anymore. But as long as you have fun and you have satisfaction and you have also your respective compensation from the either construction industry or from the political side, from government side, then your life makes sense, and that is important.
Thank you. So in my conclusion of what you said, is that to explore the underground space enthusiastically with happiness. Thank you very much, Dr. Wagner.